What monsters are hiding in the inky darkness of the universe? Can we see these monsters? What could become a peephole in the giant gates of the macrocosm, through which we could at least glimpse 1% of the mysteries of the universe? The European Orbital Observatory Euclid, with his telescope on board, has taken on the functions of such a portal. It was Euclid that, in record time, lifted the veil that for centuries had prevented us from seeing what lies in the depths of our global world. The mission was launched in July 2023 from Cape Canaveral, after which Euclid traveled to the Lagrange point, where it is now stationed. Almost immediately after beginning its work, the Space Observatory, named after the ancient Greek mathematician, presented images with astonishing clarity. And although Euclid's main goal is to search for dark matter and energy, to understand their nature and geometry by observing the acceleration of the universe's expansion, the telescope has also observed millions of galaxies, including those billions of light years away. What are the further ambitious plans for the Orbital Observatory? Its task is to create a grand cosmic atlas and a three-dimensional map covering a third of all the sky we can observe. This is a very labor-intensive mission, but if Euclid succeeds, it will be an unprecedented event in the history of space exploration. As a result, we will learn much more about how the mechanisms of the universe work than we know at the moment. The Euclid Orbital Observatory has presented a catalog that includes more than 380,000 galaxies and hundreds of gravitational lenses. This is not an exclusive phenomenon, but a common one across the universe. What did the telescope's first transmitted images look like? These are images of several nebulae and galaxies that we know, but what's striking is that no Earth-based optics had ever been capable of such clear and detailed photographs before. Moreover, no telescope had dared to look so deeply into the darkness of the dead vacuum as Euclid did. Truly, as they say, the way you name a yacht is the way it will sail. So here is an exclusive top 5 of the first images sent by the telescope. The Horsehead Nebula, the Dwarf Galaxy, Barnard's New General Catalog, 6822, the Perseus Galaxy Cluster, the Globular Cluster, New General Catalog 6397, and the Spiral Galaxy IC 342. You don't have to be an astronomer to see the obvious. Looking at these images, it feels like the galaxies were posing for the telescope in some kind of photo studio. The quality and incredible detail are mind-blowing. After Euclid sent these images, its potential and ability to create the largest 3D map of the universe in the history of space exploration became clear. This can be seen, for example, in the photo of the Horsehead Nebula, which was first discovered back in 1888 by William Fleming. It is noteworthy that it is gradually moving away from us, and after some time it will take several million years for this. It may completely disappear from Earth's horizon. This makes such photos especially valuable. So if you compare the photographs of this object taken by Hubble and Euclid, the demonstration of progress in this field becomes most evident. Here are photos of the nebula taken with other telescopes, including Hubble. The difference is obvious. That's why at the moment almost all online publications and catalogs are replacing the old images with those sent by Euclid. We have no right to blame the website developers for this, because for example, in the image of the IC 342 galaxy, without any interference from artificial intelligence or photo editors, the spiral arms are clearly visible, as if this object were in the place of our moon and not 11 million light years away. Why is the image so detailed? Previously, it was very difficult to observe the galaxy because it is located near the so-called galactic equator, or the imaginary system of celestial coordinates. What does that mean? There is a lot of dust in this location, which absorbs the radiation from objects, and that's why it's difficult to observe. But the Euclid Observatory, with its next-generation visible imaging system camera and the Corsia telescope equipped with a special design, was able to break through not only the thick layers of cosmic dust, but also through time itself. There is also a near-infrared spectrophotometer and a spectrometer on board, which also contribute to higher quality images. The scientific significance of these discoveries is hard to overstate, since active star formation most often occurs in the regions of nebulae. The Icon Head is no exception, and that means we are now able to penetrate into the very essence of the universe, to get closer to the crucible where new stars are forged. What else has the Orbital Observatory become famous for? In May 2024, Euclid sent new images to Earth. Thanks to this, we were able to take a closer look at the Dorado Galaxy Group, the Spiral Galaxy New General Catalog 6744, the Able 2390 and Able 2764 clusters, as well as examine a star-forming region, Messier 78. The European Space Agency, with undisguised excitement, released these images, commenting that the photos from this telescope are a true triumph of science, allowing scientists in the future to hunt for rogue planets and actively use lensed galaxies to study the matter of the universe, as well as to better understand the laws of evolution of our world. But that's not even the most interesting and amazing thing that happened in March 2025. It was during this period that the telescope observed deep fields of space and recorded 26 million galaxies, the most distant of which are located up to 10.5 billion light years away. Let's start by clarifying the terminology. Deep fields are relatively small areas of the sky that Euclid paid special attention to, observing them for extended periods. As in the well-known meme, if you stare into the abyss for a long time, it begins to stare back at you. This method is perfect for looking into the very distant past of the universe, literally back to its very origins. Here are the visual results of what Euclid was able to see. Among the telescope's goals is not just mapping and generating images. The Orbital Observatory is also designed to measure the cosmological parameters of each object. However, the most important thing that scientists plan to find out with the help of this space station is to solve the mystery of the phenomena of dark matter and dark energy. These are the most mysterious components of the universe, about which, at the moment, we only have theoretical and very approximate knowledge. These components directly affect the fundamental principles of the universe's evolution. What are dark energy and dark matter? Simply put, the main problem in studying these components, which are key in modern cosmology, is that they cannot be seen or measured in any way, since they neither emit nor reflect light. At the same time, they directly affect the evolution and structure of the universe. For example, dark matter. What is its essence, and how do we find out that it exists? Dark matter reveals itself through gravitational influence, meaning it is what holds galaxies together with gravity. So it's the foundation that holds everything together. What is dark energy then? It's an even more mysterious substance, supposedly causing the accelerated expansion of the universe. It's believed to make up about 68% of our macro world. Why does it contribute to expansion? The thing is, dark energy is hypothetically characterized by negative pressure, which leads to the repulsion of molecules and consequently the expansion of space. So it turns out that dark energy and matter work in tandem, even though they have completely opposite properties. The first repels particles and contributes to the expansion of the universe, while the second, on the contrary, attracts them, which allows the formation of galaxy clusters and other megastructures. So, the mission of the Euclid Observatory is precisely to study this issue in more detail. How will this happen? First of all, by measuring the redshift of galaxies and studying their characteristics. The discovered gravitational lenses indirectly confirm the presence of dark matter in the universe, just like the microwave background. But the most important thing is what we see with our own eyes. Galaxies really do not fall apart, and the stars on their outskirts move faster, which indicates the presence of additional mass that does not match visual observations. If there were no dark matter, the cosmic web consisting of walls, filaments, and voids would be impossible. Such structures require additional mass to explain their formation, as well as their stabilization within these shapes. That's exactly what Euclid is doing. Is there concrete evidence of the existence of dark matter provided by a space observatory? Yes, these are images of the Perseus and Abell 2,390 galaxy clusters with the effect of gravitational lensing, which in itself is evidence of the mentioned fact. The Abell 2,390 galaxy is located about 2.7 billion light-years away from us. A gravitational lens creates distorted shapes by bending space-time, which helps us see incredibly distant objects more clearly. But for this effect to occur in practice, the mass of the mentioned objects is not enough. Obviously, there is a huge amount of invisible and unaccounted for matter present. This is what we call dark matter. In the future, Euclid will create maps of dark matter distribution based on observations of millions of galaxies, and will determine the laws governing the existence of this invisible skeleton of the universe, which acts as a gravitational glue holding everything we see within structural frameworks. But has Euclid found evidence of the existence of dark energy? The Space Observatory is currently in the process of determining the redshift parameters of billions of galaxies, and the aforementioned deep field method is especially helpful in this. In this way, the telescope can peer into different periods of galaxy development, track their evolution, and understand how dark energy and dark matter influence their formation, and essentially on the universe's fabric. So, the interim results and figures, the goal of the Euclid Space Observatory mission, are quite clear, but what is the significance of its current and future discoveries for global science? First and foremost, it's about uncovering the nature of the universe, its laws, and the nuances of how it functions. Secondly, Euclid's discoveries will help improve our understanding of the structure of the macrocosm and the evolution of its objects. Continued. As for more global predictions, such research stimulates the development of astronomical science, especially in terms of tools and technology. And most importantly, it expands our knowledge about the nature of things and physics as a whole. Research into such phenomena will most likely lead not only to new discoveries, but also to a serious modification of existing cosmological theories. That's why the mission of the Euclid Space Observatory cannot be overstated. It's important by default. Our attentive viewers might ask, why spend astronomical amounts of money on launching an innovative project if James Webb is already operating successfully and delighting us with new discoveries? There is a reason. Since the tasks of these telescopes are different, James Webb is focused on studying smaller areas of the universe, while Euclid surveys much larger regions. You could say that a space observatory is a revolutionary phenomenon, comparable to the Gaia telescope, which gradually changed astronomers' understanding of the laws of our Milky Way galaxy. If you have any questions after watching the video, feel free to ask them in the comments. Well, Earthlings, this is not the end of the video. We still have some very interesting and simply spectacular episodes ahead of us. But for me to keep delighting you with all the characters of the cosmic expanses, I need your feedback. You can express it quite simply. All you need to do is give an electronic like under this video, since we simply don't have any other kinds of likes, and I know how to continue the phrase. This way, you'll let me know that we're moving in the right direction. Don't switch channels.